Evening. Today we will be going to present our project on credit card fraud detection using Python. The aim of this analysis is to understand how fraudulent transactions differ from genuine ones and to build machine learning models that can help detect these frauds in real time. Our team member includes myself, Ekant Chauhan, Gagan Sharma and Karthik Singh. The dataset which we have used is a real-world credit card transaction dataset which contains features like transaction amount, gender, category, transaction time, and whether the transaction was fraud or not. Before doing any analysis, we first validated the dataset. We checked for missing values, inconsistent formats, and duplicate entries. There were some duplicate records which we removed, and we ensured that all data types were appropriate for analysis. This step is crucial because any errors here can lead to misleading results. Exploratory data analysis. Once the data was clean, we moved on the exploratory data analysis or the EDA. We first tried to answer the question, what patterns or trends are common in fraud cases? First, we looked at the transaction amount. We filtered the transaction under $1,000 to focus on the majority. The bar plots showed that while both fraud and non-fraud occur mostly at lower amounts, fraud was slightly more common in certain mid-range values like from $200 to $400. Next, we analyzed gender distribution. This results show that both male and female customers were equally targeted by fraud, which tells us gender alone doesn't predict fraud well. Then we examined fraud across different spending categories. This was very insightful. Categories like travel, personal care, and entertainment had much higher fraud rates than others like gas or grocery. This suggests that fraudsters might be targeting specific types of purchases. Coming on to feature engineering, after EDA, we moved to feature engineering. We created new features from existing data, such as extracting the hour of the day, the weekday, and the month from the transaction time. We also calculated the age of the customer from the date of birth, which allowed us to see how fraud varies across age groups. Interestingly, younger users, especially those under 30, had a slightly higher fraud rate. Finally, we applied one-hot encoding to categorical columns like gender and category, so they could be used in the machine learning models. We trained 3 different models: logistic regression, decision tree, and XGBoost. Logistic regression had decent precision but a lower recall, meaning it missed some fraud cases. Decision tree improved recall but tended to overfit, while on the other hand, XGBoost performed the best overall, balancing both precision and recall effectively. We plotted ROC curves and precision recall curves to visually compare the models. As you can clearly see, XGBoost had the highest area under the curve in both plots, confirming that it was the most reliable model for our problem. To conclude this project helped us understand how to analyze real-world data, validate and clean it, perform meaningful EDA, engineer features, handle imbalance, and build predictive models. We also learned that fraud isn't random. It follows a pattern. Features like transaction category, time, and user behavior can give valuable signals to detect fraud early. Thank you.